Hello everyone, I am Abdullah Abu Alim and I'm going to present the motivation, methods and results of our entire challenge for defocus deblurring using dual pixel images. This challenge is in conjunction with CVPR 2021 and my co-organizers of this challenge are Radu T. Moft and Michael Brown. To motivate the need for this challenge, let's first start with some basic camera concepts like camera exposure. So the aperture size is the first factor that controls the amount of light traveling through the camera optics at a certain time point. So larger aperture means more light. The other factor is the time you want the imaging sensor to expose the light. So faster shutter speed results in less exposure. Now, the relationship is an inverse relationship, where the exposure is correlated with aperture size over shutter speed, as shown here in this equation. One important note, ISO sensitivity is also another factor to control camera exposure that is used as a measure of the camera's ability to capture light. But for simplicity, I'll only focus on aperture size and shutter speed in this presentation. Let's take our first use case of a larger aperture. In this case, you have a dark scene under low light conditions, and you capture the scene with a small aperture. Then this will be the result. So what you want now is more exposure to get a properly exposed image. To do so, let's assume the shutter speed is fixed to avoid motion blur. Then you have to go with a wider aperture to get more exposure. And by capturing the image with a wider aperture, you get this nice and properly exposed image as shown here. Larger aperture also enables faster shutter speed. In this case, the Newton cradle is moving fast and you captured an image at a small aperture. Then you have just realized the shutter speed needs to be faster in order to avoid motion blur. One way to do so is to go for a wider aperture, given that you want the exposure to remain the same. And by capturing the image with a wider aperture, you get this nice blur-free image as shown here. However, capturing an image with a wider aperture will affect the camera depth of field, in which it gets shallower and then produces more defocus blur as shown here in this example. Here we have a real scenario of capturing two images that have the same exposure but different aperture and shutter settings. The top one was captured with a small aperture and low shutter speed, whereas the bottom was captured with a larger aperture and thus faster shutter. The top settings result in motion blur, and the bottom one suffers from defocus blur. Now, we have two options to deblur the images. First, motion deblurring using a state-of-the-art method, or second, defocus deblurring using our method published in ECCV 2020. So for this specific case, option 2 is the way to go, as the deblurring results are better. And the message out of this is that defocus deblurring is as important as motion deblurring in many cases. However, when you Google search defocus deblurring versus motion deblurring, you get this, about 37,000 results for defocus deblurring, whereas you get about 243,000 results for motion deblurring. So about 87% of the results are motion deblurring, and this shows defocus deblurring gets lower attention even though it is very important. Not only that, but also in academia it is very rare to find defocus deblurring papers, whereas you find many motion deblurring papers published every year. Last year we published our defocus deblurring paper in ECCV 2020 in order to revisit this important problem. Now you can think of a shift in camera manufacturing paradigm, especially for video cameras of applications where the camera moves very fast. We can even think of a better quality cameras with larger aperture and reliable autofocus mechanism with a defocus deblurring unit running on top of that. After we stated the motivation behind defocus deblurring, this challenge aimed to gauge and advance the state-of-the-art in reducing defocus blur and attract more attention to this important problem. Given an image that has a spatially varying defocus blur, the main goal of this challenge is to reduce the effect of undesired defocus blur. Before I go to talk about the dataset, I want to talk about the dual pixel sensors or DP sensors. These sensors were designed by Canon to assist in camera autofocus. These sensors are designed with 2 photodiodes at each pixel location on the sensor. The DB sensors produce 2 sub-aperture views of the scene, denoted in this work as left and right views. These views are mainly used to calculate the appropriate lens position to focus on a particular scene region and are discarded afterward. Here, we alternate between the left and right dual pixel views, and the amount of motion present is correlated with the amount of defocus blur. Therefore, DB views can provide a good cue for defocus deblurring and are used as input in our challenge. The training data used for this challenge is the 500 paired images from our ECCV 2020 DB dataset. This data has input DB views of a blurry image with its corresponding all-in-focus image. For the validation data, we captured 50 more pairs and only inputs were given to the participants. The same holds for the testing set as well. As for the challenge timeline, the validation stage started on January 6 of this year and lasted for 10 weeks. Then in March 15, we opened the final testing stage that lasted for 5 days. On March 20, we closed the server and announced the end of the challenge. Then on March 26, we shared the results with the participants. Here are some statistics. We had 198 registered participants, including 9 teams that provided methods and competed in the final stage. For evaluation, we used the conventional signal processing metrics PSNR and SSIM. This table summarizes the results of the 9 teams who competed in the final stage. We have the team names along with PSNR, SSIM, and runtime results. The subscript between the parentheses is the team ranking based on the given metric. We have also the type of a processing unit used and the programming platform. Samsung Research China Beijing SRCB achieved the best results based on the 3 metrics, and their method is the best performing one. So congratulations Difang Zhan and Xiaobin Wan for the great job. Here I'm also showing a 2D visualization of the combined PSNR and SSIM values. Each team name is shown next to each start marker. Here is a quick overview of the architecture proposed by SRCB team. So mainly their proposed network has 3 main modules: feature extraction, fusion module, reconstruction unit, and upsampling net at the end. Further details of this method and other proposed methods can be found in our NTIRE workshop paper, so scan the QR code to reach the paper. To conclude, we had 9 teams competed to the final stage. The methods achieved the state-of-the-art results for defocus deblurring. SRCB team achieved the best results for all metrics. And finally, we aim by this challenge to shift the researchers' attention to an important research problem, defocus deblurring, and we showed that motion and defocus blur are results of a specific capturing settings, and then it's also worth thinking of a joint motion defocus deblurring. Who knows, that might be the trend of the next generation cameras. Thank you.